You must be really desperate if you're watching this. I'm going to explain how to figure out sig figs. So this is just a review on sig figs. Okay, there are 4 rules for sig figs. Okay, so let's just go through these guys. Right, if you have if you've got a digit right at the leftmost non-zero digit is the most significant digit. Okay, so if you've got 300, that's the most significant digit. If somebody, for a joke, prints, 0, 300, right? This one is the most significant digit. Okay? So that's easy, right? The most significant digit is just the one that is the furthest to the left. Okay? Our next rule is, and this is if there's no decimal point. Okay, if there is no decimal point, the rightmost non-zero digit is the least significant digit. So let me just show you what that means. Let's suppose we got 31. That's the least significant digit. So that's simple, right? What if I've got 30? No decimal point. There's no decimal point. So this is actually the least significant digit. It's the least and it's the most. There's only one sig fig there. Okay, so if you say 30, no decimal point, you mean about 30. If you mean 30 with an uncertainty of, down in the tenths or something, right? Then you say 30 decimal point, and then this rule doesn't apply. This one still is the least significant digit. Okay, what if I have 210? Well, there's no decimal point, right? So this is the least significant digit. That's the most significant digit. There are 2 sig figs right there. Okay, so if there's no decimal point, the rightmost non-zero digit. What if I say 300? Well, there's no decimal point, right? So I mean about 300. It's wildly inaccurate. The least significant digit is the 3, and the most significant digit is the 3. There's only one sig fig there. Okay? No decimal point. All right, good. All right, next rule. Okay, if there is a decimal point, the rightmost digit is the least significant digit, even if it is a 0. Okay, so if I say 3.00, there is a decimal point here. So this is my least significant digit. That's my most significant digit. That's 3 sig figs. You should ask yourself when you see this number, why did they say 3.00? That's because they measured the tenths place and the hundredths place, and they just happen to be 0. So this thing has 3 sig figs. Okay. What if I go 0.0120? Well, this 0 here is just power of 10. So this is the most significant digit, right? So it's always the leftmost non-zero digit. These guys never count. Now you ask yourself, why did they put that additional 0? Well, they measured it, and it is 0. Just, hey, it's not approximate. We know it's 0. So this is actually 3 sig figs as well. Okay, so if there is a decimal point, the rightmost digit is the least significant digit, even if it is a 0. Okay. Are there any other things? How about 30.0? Well, this is the most significant. There's our least significant. If there is a decimal point, it's just the rightmost digit. Okay? And then the final rule is all digits between the least and most are also significant. Okay? So let's just go through some examples here. Okay. 3,000 and 3,010, right? Here's our most significant. Here is our least significant because there's no decimal point here, right? So this is least, that's most, that's 3. Okay, next one. All right, so now there is a decimal point. So this is the most significant. This is the least significant, right? So that's 1, 2, 3, 4, 5, 6. All right. Let's look at the next one. 20, no decimal point, right? So this is the most significant, and it's the least significant. That's 1 sig fig. If you say that, you mean about 20. Okay? 20 with a decimal point. Hoo-hoo. Well, now you measured the ones place, and you know it's 0. You don't know anything about the tenths place, but you know this one. So this has a decimal point, right? This is how you would write 20 with 2 sig figs. Okay? So this is the most significant. That's the least significant. That's 2 sig figs. Okay, this continues to get precise, right? Now it's 0.0. Why is that 0 there? We measured the tenths place. We know it's 0. And then this is the most significant, least significant. That's 3 sig figs, right? All right, what's the next one? Okay, so 30.010, right? Here's our most significant digit, and then this is our least significant digit, this guy here, right? So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 sig figs. Yeah, there we go. Let's do some more. All right, yeah, kids hate this, right? 100. Well, no decimal point means it's wildly inaccurate. You're just saying about 100. So this is our most significant digit and our least significant digit. That's 1 sig fig. All right, this is, in scientific notation, it's just simple. Just count these guys up. There's always a decimal point in scientific notation, right? It's always something point something something something, right? So this is just simply as many digits as you have. This is, by the way, called the mantissa. That's the exponent, right? So there's 2 sig figs there. If you wanted to write 100 with 2 sig figs, these are the same number with different precisions, right? Okay. If you wanted to write 100 with 2 sig figs, this is how you do it. That's the way to do it. Okay, how about this? 100 decimal point, right? You could also write it, that's 3 sig figs, right? There's a decimal point, least significant, most significant, 3. You could write it this way, 1.00 times 10 to the 2, right? You could write this 1 times 10 to the 2, right? And so the cool thing about scientific notation, hence the term scientific, right, is that the number of digits in the mantissa is the number of sig figs you have. All right, kids always hate this one, right? But leftmost zeros never count, right? So if I wrote this in scientific notation, it would be 1.2 times 10 to the, let's see, 1, 2 to the minus 2, right? So that's 2 sig figs. Most significant, least significant. That's 2 sig figs. All right, so these zeros don't count, right? This would be 1.50 times 10 to the minus, let's see, 1, 2, 3, 4, 10 to the minus 4, right? So that's 3 sig figs. If you ever have a question about something, just put it in scientific notation. It's always easy, right? That's 3 sig figs. Least significant digit, most significant digit. How about 37 people in a class? Well, if it's a precise number like that, if I really count it and I'm sure of it, it doesn't count for sig figs. It's not like we're uncertain in the tenths place, right? It's not like point we don't know. There's not like there's like an arm or a leg lying on the ground that we aren't lost track of or something like that. Okay, so if they start talking about 50,000 people at the mall, the National Mall or something like that, that's probably uncertain, and we'll deal with that with uncertainty. Okay, so anyway, there you go. Hope that helps. We'll do some more examples here.